And well, people, the time has come.
If you wanna go, then you go to hill and go down.
Why you get
Okay,
fried,
yes,
man?
why? Are you crazy?
You're fucking paranoid,
You are
man.
fucking, you are fucking.
You fucking, you bloody,
You bloody-
fuck you bloody bastard bitch. You.
The time has come for me to make a video about how to GeForce the same way that I made one for How to Adrenaline 2025. And I say how to GeForce 2025 and how to Adrenaline 2025 because, well, we're almost in 2025, it's the 1st of December, and I want people to watch the video in 2025 and do not think that the video is outdated by any means. They might have some newer options here and there, but usually the base of the question, the base of the software will exactly be the same, so this video will still apply for 2025. And by the way, I know some of you guys were expecting this video way sooner because I told you that the video will come out way sooner, but in the meanwhile, I was a bit sick as well, my wife was a bit sick as well, so yeah, we had some things to do, and this is actually the second time that I'm recording this video because the first time I somehow deleted the file of the desktop recording and I was so mad. I even tried to install some recovering software in order to recover the file, but yeah, no luck whatsoever, so I'm here recording again. And this is basically a video where I show you all the NVIDIA settings that you have, what they do, what they serve for, and what option should you pick, on, off, enabled. And if you are not used to long videos, you're in for a tough ride. Even though for some people it might be really worth it to watch the video to its full length in order to get some information from my comments. Now, the first thing that you want to do is right click on your desktop, and it is actually baffling how NVIDIA, after so many years of Windows 11 already, NVIDIA still did not add the NVIDIA control panel option to the Windows 11 menu. You have to go to the show more options and then the NVIDIA control panel will appear. Or you can just go, if you have the desktop icon, you can just open the desktop icon and it will work the same way. And by the way, some of you are still using the NVIDIA control panel and NVIDIA GeForce Experience, but the NVIDIA app just went out of beta. It is official now, you can download it outside of the drivers, but it will integrate the drivers pretty soon, so it would make no sense to make a video pushing 2025 and not using the NVIDIA app whatsoever. Especially since the NVIDIA app grabs NVIDIA control panel and NVIDIA GeForce Experience and meshes those two up to form a better and faster application. Almost as great as to the sponsor. Today's video sponsor is GVG Mall, bringing you lots of software deals like Windows 10, Windows 11, Office 2019 or 2021 with a new Windows 11 design, and for all of these you can use my SKG discount code for 30% off, getting a Windows 11 serial key for $22 and a Windows 10 one for only $15. Then use the key on your Windows settings and you'll have an activated system. So as soon as you open the app, you have several menus: the home menu, drivers, graphics, system, redeem, and settings. And on the top right corner you have the open overlay, Alt+Z, the send feedback, and the login. And one of the things that I like the most about the new NVIDIA app is that you don't need to log in. And that really annoyed the hell out of me when I was using GeForce Experience, because I use NVIDIA Shadowplay, or whatever you want to call it, NVIDIA recording features to record the games when using an NVIDIA card. And even though I could use the NVIDIA control panel without any need of logging in, I needed to log in order to use GeForce Experience, which was kind of annoying because I had like this huge list of emails from NVIDIA just because I needed to confirm the login and so on. Gladly, we do not have to do that anymore with the NVIDIA app, which is great. But well, let's start with the home menu, and with the home menu we actually have the propaganda here. So game ready drivers with Stalker game ready drivers. Then we have the library with the apps that we have, OBS, The Last of Us, Starfield, and so on. And if you want to go directly here to these applications or games, you can just go, for example, and you go immediately to the settings that are presented on the graphics menu, but we'll get there. And at the bottom we have Discovery, where we have other NVIDIA software like the GeForce Now that I have passing right now in this video, where you can just play your games through NVIDIA's computer. So all you have to do is have an account. You have to pay monthly, of course, but you are able to play even on your computer, tablet, and so on, using NVIDIA's computer and your internet service. Then we have NVIDIA Broadcast, that actually has a vast set of features for people that like to broadcast, stream even recording and so on, AI-powered live streaming according to NVIDIA, of course, RTX voice suppression where you can suppress the background noise that we have. For example, if you have a fan noise, if you have for example, some construction workers around your house and you have that background noise, you can use RTX applications to actually fix it.
But it's a bit in the distance, so it shouldn't be too much of an issue. But let's see what happens when we enable RTX voice. Alright, so RTX voice has been enabled. As I'm speaking, you can probably hear that that's been heavily muted and only my voice is being picked up clearly and with a little bit of processing that happens to my voice, but like totally acceptable, right?
Then we have the Omniverse for 3D content creation, the NVIDIA Canvas, which is actually an interesting feature, paint with AI, turn simple brush strokes into realistic landscape images with AI. And I've seen this before, and it really works well. You just have to do, literally, it's like a brush stroke of a tree, of a landscape, of a house, and NVIDIA Canvas will do exactly the same. Let's say that the NVIDIA Canvas software or the AI in that software will paint what you imagined, or at least very close to what you imagined in, well, better quality. Then we have the iCAD software, which according to NVIDIA, and let me just see because the camera is in front of it, make image quality comparisons with speed and ease.
Or use the drop-down scaler. Once zoomed in, panning around the media allows you to really analyze the image quality.
Then we have the frame view that measure frame rates, frame times, latency, power, and performance per watt. And then you have the chat or the chat RTX. Connect a local large language model LLM to your docs, notes, and images for something. Basically, you just have a chat on your computer. It's kind of ChatGPT, for example. You can just ask it several things and it will answer. Nothing new, but you have the option to get it. As soon as we go to the drivers menu, you have this little text saying that the drivers are up to date with the game ready driver, and you can select in between the game ready driver, which provides the best gaming experience, or the studio driver that provides the best experience for creative apps. And not only in terms of creative and gaming. Game ready drivers for the biggest amount of optimizations for newest games, and studio drivers for stability, performance in studio applications, and so on. Then we have the driver we have installed, GeForce Game Ready Driver, version 566.14, released Tuesday, November the 12th, 2024, and you have the option to reinstall it if you want to, and we have other ads like Stalker 2 and so on. And then we have on the bottom, our newest GeForce Game Ready driver delivers day one support for Stalker 2, Heart of Chernobyl, and Microsoft Flight Simulator 2024. Two new, highly anticipated titles that feature support for the DLSS 3 with frame generation and super resolution, and NVIDIA Reflex. I like this part of the new NVIDIA app where they tell you kind of what the drivers are meant for or specifically made for, and then you can learn more, and this redirects you to the NVIDIA website if you want to. Otherwise, you just have this small window where you have more information of the drivers. For example, you have a little video on the NVIDIA app. You have the game ready drivers and the SCAR trailer for Stalker 2, and some charts and so on. This is a really nice thing that NVIDIA does here. Then you have what's new game ready driver once again for Microsoft Flight Simulator, featuring DLSS and blah blah blah. Stalker 2, then we have optimal settings that were added for new games, like Call of Duty Black Ops 6, Delta Force, Dragon Age the Veilguard, Horizon Zero Dawn Remastered, and Red Dead Redemption, the first one, not the second one. And then we have what's fixed. With gaming being fixed, Call of Duty Modern Warfare 3, file name change preventing users from GFE freestyle filters, DSR/DLDSR, custom resolutions may not appear in certain games, BlueStacks and Corsair IQ may display higher than normal CPU usage, and when shader cache size is set to disabled, cache files may still be created. So according to NVIDIA, these were the issues fixed with these drivers, and of course, they won't show you the known issues. They know that they have known issues. You can see the known issues in several release notes, but they won't show the known issues on software because the known issues would make them look bad, but it's kind of understandable. Still, it's nice to see what was fixed. Then we have the graphics tab, And on the graphics tab we have the program settings and the global settings, and the program settings are basically the in-app settings plus the global settings, but on a per app basis, meaning that these settings can be applied to a game specifically and not the others. On the global settings we start by having the driver settings where we can restore the settings in case we change them, and then we start with RTX Dynamic Vibrance, which according to NVIDIA boosts visual clarity for your games using AI. RTX Dynamic Vibrance uses AI to improve visual clarity for your games. RTX Dynamic Vibrance, once again, is content adaptive, prevents color crushing, and works on a per app basis. You can manually adjust your preferences in the overlay on a per app basis. There are quite some people that use this for single player games, but in my experience and from what I've heard, this is mostly used for competitive games, people playing Warzone, people playing Counter-Strike 2, because there in some of those games and in some of those maps there are some parts of the maps that have shadows, and the player models are usually a bit darker as well, so it's hard for you to see the player model when it passes through the shadows or through darker scenes. And with RTX Dynamic Vibrance it actually increases the saturation, so you can actually tell the player from the background way easier because the player will have more saturation, more brightness, and so on. That's basically what people use it for. But there are people, of course, that use it for single player games because they just like a more saturated image, or they have a lower end monitor and they want kind of a more punchy color vibrance. Yeah, maybe that's it, I don't know. But I do know that most people use it for competitive games. Then we have RTX HDR that, according to NVIDIA, adds HDR support for non-HDR games using AI. RTX HDR is a game filter that uses AI to add HDR support for DirectX and Vulkan games. You can manually adjust your preferences in the overlay. If you don't know what HDR is, it's basically if your monitor supports HDR, you have a high dynamic range of colors, and generally it will bring you a better picture. And most people use this especially with OLED, since OLED has a lot of quality and people use HDR on top of OLED to increase their experience. In my opinion, yeah, I don't really use HDR. And you might even say, well, but you don't have an OLED monitor, so you can't actually say. You never tested HDR with an OLED monitor. Well, I'm actually recording this video with an OLED monitor, 42 inches, and I'm still telling you that I just don't like HDR. I don't use HDR, I don't like HDR. First of all, due to the excessive brightness. I like my monitors with low brightness, and as soon as I press HDR or I use HDR, I need a lot of brightness in order to have that high contrast in between whites and blacks and so on. And yeah, that's just a big no for me. I don't want to be blind with the OLED brightness. I just want to enjoy my experience. And if you already have an OLED, I mean, the image quality is just insane already if you have an OLED, so you don't really need HDR to increase that experience. But if you can, and if you're playing a game that does not support HDR natively, for example an older game or a newer game that just didn't came with HDR support, and you are in for HDR, full steam ahead, then you have RTX HDR that uses AI to give HDR to your non-HDR games or applications. And from what we've seen so far, it works very well and people love it. So if you're into HDR, this is a big yes. Then we have CUDA and the GPUs, which shows the GPUs that you have here on your system. If you have several NVIDIA GPUs, they will show here. Let's say that we have an RTX 4060 and the 4080 in the same computer. As soon as I click here, it would show RTX 4060 and then in the bottom RTX 4080, and I could select in between these two cards for the applications that I want to run. Let's say that I'm connecting the display to the 4060, but I want the 4080 to run the games. I could select the 4080 here and the games would run on the 4080. At least that's what happened with the previous NVIDIA control panel. Then we have DSR factors. Dynamic Super Resolution DSR produces smoother images by rendering a game at high resolution, then downscaling it to the native resolution of the display using advanced filtering. Dynamic Super Resolution can be applied to any game and can be used with other anti-aliasing anti-aliasing settings to improve image quality. Then this is an interesting thing that we have here as well. Typical use scenarios or usage scenarios, a thing that AMD should add as well. Improve the quality of anti-aliasing on games that do not have any in-game anti-aliasing settings or for games where the in-game anti-aliasing is insufficient. Or enjoy better image quality for older games. Imagine that you have a 1440p monitor, but you have a really big 1440p monitor, let's say like 42 inches 1440p. As soon as you have like 42 inches 1440p, what happens is that your pixel density is quite low. So if you go closer to the monitor, you would be able to see the individual pixels of the monitor. And that looks quite bad. Even if you're playing at 1440p native in a monitor like that, you could see the pixels and the gaming experience won't be that great. So what you can do is use the SR, go and pick a resolution of 4K, and the software, in this case the NVIDIA app, would downscale the 4K quality, so you would render at 4K, meaning that of course you need a better GPU or you would need more GPU power. You would render at 4K and then it would downscale to 1440p in order for it to look, for the image quality to look better. And it would look better because, for example, if you have 1440p, you have more pixels than 1080p. And if you have 4K, you have way more pixels than 1440p. So if you kind of take that whole information from 4K rendering and put it in the same pixels that 1440p have, you have way more information to put in the same amount of pixels, meaning that with the right filtering, it would look much better. It would kind of smoothen things out because you have way more information and you wouldn't be able to distinguish the pixels individually the same way that you did with native resolution at 1440p. For some people it might look better, for some it might look worse, but generally if you have a low pixel density monitor, DSR is really a good way to kind of fix that, at least. Well, I wouldn't say fix it, but it's kind of a good way to enjoy a better experience in the same monitor that you have. Then we have image scaling, increases frame rates with GPU upscaling and sharpening. NVIDIA image scaling enables spatial upscaling and sharpening for all GeForce GPUs and games. You can manually adjust the sharpness in the overlay. And then we have information. This setting will take effect the next time you launch the game, blah blah blah. And the typical usage scenarios are: turn image scaling on to boost your frame rates of your application, use sharpen to adjust the level of sharpness, and use overlay indicator to show if feature is enabled for your application or properly captured in the screenshots or videos. Image scaling, really interesting feature because image scaling is what it is. It's basically what we know so far of upscaling. We have the LSS, we have FSR, and we have XeSS, and image scaling is basically using the algorithm from the LSS1 that used spatial upscaling. The LSS1 and FSR1 use spatial upscaling, which is not as great or as good as temporal upscaling, which is the one that we have right now with the newest versions of the LSS and FSR, and that's why they went to temporal upscaling in order to have more information from the game, like depth vectors, velocity, and so on, in order to have better upscaling quality. And what you can do here is quite simple. If you go for the image upscaling and you open it, you have the option to press on. Then we have the render resolution and the sharpen percentage. So if you're playing an older game that does not support the LSS, you can just go to the image scaling, select, let's say 67%, which is the quality mode, or if you want better quality more than this, then enable the sharpen level according to your resolution. Usually, the lower the resolution, the higher the sharpening level, in order to make the image feel like sharp. Otherwise, it would look like crap. But I would say that 67%, 77%, or even 85% are the ones that you should pick. Usually 77% would be fine with, let's say, like 65 or 70% of sharpen effect, depending on the game, of course. This is for games that do not support the LSS. If the game supports the LSS, just use it because you have a way better upscaling algorithm there. Just do it. Then we have the low latency mode. The latency control reduces latency by limiting the number of frames the CPU can prepare before the frames are processed by the GPU. Then we have select off, on, or ultra. And this is basically what it is and what it says it does. It is a low latency mode that you can select. It's basically like Reflex. On the Reflex options inside the game, you have NVIDIA Reflex off, NVIDIA Reflex on, and NVIDIA Reflex on plus the boost. And this works the same way, off, on, and ultra, which is basically on plus boost. If you have a GPU or if you have a CPU that can do much more work than the GPU, let's say your CPU is really powerful and you have kind of a mid-tier GPU, your CPU will kind of keep producing frames and wait for the GPU to render them. They will just get in the queue, and that kind of adds latency to your pipeline. So what the low latency mode does is that it tells the CPU to not produce any more frames or not produce more than a set amount of frames until the GPU renders them. So the CPU will have one frame ready to be rendered, the GPU will start rendering that frame, and the CPU will start producing another one. While normally if your CPU is way more powerful than your GPU, the CPU will produce, let's say, 1, 2, 3, 5 frames, and then will wait for the GPU to render them. And as soon as the GPU renders one, it will produce another one to get in the queue. And you don't really want that if your goal is to achieve low latency. So if the game does not support NVIDIA Reflex, most of them do, but if the game does not support it, you can just go here and select the on or the ultra mode. That's it. Then we have the maximum frame rate option that sets the maximum frame rate that the GPU will render a game or 3D application. Limiting the frame rate can be useful for extending battery life or reducing system latency in certain scenarios. And yeah, this basically is what it is. It's a frame cap that you can use. You can just go here, select on, and select the frame capping that you want to do. And it says that it can reduce the latency in some case scenarios, and it can. Because if your GPU is really at tops, pushing the maximum that it can, like 100% usage, 99, 100% usage all of the time, if you lower the FPS, or in this case, if you lock the FPS to a lower amount, the system will have lower latency because the GPU will have kind of more room to work with other things while not being at 99 and 100% all the time. And by the way, if you're using a software, let's say like lossless scaling, and you are using the lossless scaling to let's say to generate frames, to use frame generation on your games, you want to lock the frame rates. If you're not using RTSS, for example, you can use the NVIDIA app. Let's say that you have a 144 Hz monitor. Then you want to lock the FPS to, let's say, 71, a little bit below the ones that you want. Let's say that your game is getting 90 FPS. You lock the FPS to 71, so 71 times 2 will be 142, which is 2 frames below your refresh rate in order to avoid fluctuations and in order to avoid tearing mostly. And then as soon as you have 71 base frames, you run lossless scaling and you'll go up to 142 and you'll have a smoother experience with lower, well, I wouldn't say lower latency, but with lower power consumption because of course you're using frame generation and you're locking frames. So it's a good option, again, if you're using things like lossless scaling, or if you just want to save some power because you're getting 200 FPS and you don't really need 200 FPS because you have a 144 Hz monitor. Then you just go here, just lock the frames to 142 and call it Jesus Christ, and call it a day. That's it, you save power and you'll be inside your FreeSync range, making your gameplay way smoother. Then we have monitor technology, which is basically VRR, or a variable refresh rate. In this case, it appears G-Sync since we have an NVIDIA card, or fixed refresh rate, which is basically just, yeah, no VRR whatsoever. And if you want to know more about variable refresh rate, you can watch this video passing right now on the screen, where I explain how it works, where is the range, what it serves for, G-Sync, FreeSync, variable refresh rate. I show everything there, how it works, what you need to know about it, the history of the technology, and so on. Then we have the power management mode. So this feature allows you to set the preferences for your graphics card's performance level when running 3D applications. You can select in between the preferred maximum performance or the normal default. This will mostly do a difference when we're talking about mobile processors or mobile processors and mobile GPUs. Or let's say GPUs that are power restricted somehow. In those case scenarios, that will make the difference. But if you're running a desktop computer, this won't make any difference, and you should always pick the preferred maximum performance. Then we have the shader cache size that controls the maximum amount of disk space the driver may use for storing the shader compiles. Typical usage scenarios, shader compilation for applications can be skipped if the result of that compile can be found in the cache. So basically, if you already have the shader cache done, you don't need to compile it again. I guess, and I believe that's the case. And as for the options, we have driver default, then we have unlimited 100 gigabytes, 10 gigabytes, 5 gigabytes, 1 gigabyte, 512 megabytes, 256 megabytes, 128 megabytes, and disabled. And if you don't really know what is the shader cache, for example, when you're running into the game or into newer games like, let's say, Space Marine 2, like Silent Hill, the game will load the shaders, and that's exactly what the shader cache is for. It is that space on your disk where it will kind of, save the shaders that you load from your games. And the biggest amount of shaders that you have loaded, the lower the stutters will be. There are some games where you're running, let's say, even if your card is NVIDIA, AMD, Intel, doesn't really matter. As soon as you run into the game, even if you load the shaders in the beginning of the game, like once again, Space Marines 2, Silent Hill, there are always some smaller shaders that are loaded as you go into the game. So as you enter a new area, some new shaders will be loaded, and that's why you have those little stutters when you enter the area for the first time. As soon as the shaders are loaded and they are saved on your disk, what happens is that as soon as you enter that new area, you won't have those stutters anymore. And you won't have those stutters anymore because the shaders are already loaded. And in this case, the driver default might be kind of a dynamic partition to save the shaders or something like that. And if you don't want to have the shaders compiling, you can select disabled, or you can just give it unlimited space, whatever. But for the common user, 99% of people won't have any benefit using anything other than driver default. That's what I believe. Then we have vertical sync. Again, vertical sync is a collection of settings that controls how the GPU render state interfaces to the refresh rate of a monitor. This setting is applicable only when a display is connected to the NVIDIA GPU. Vertical sync, once again, it appears also on this video passing right now on the screen where I show you what FreeSync, VRR, vertical sync, everything. I show you what everything is and how it works. And the difference in between G-Sync and vertical sync is that vertical sync avoids tearing. In order to use vertical sync without tearing, you need to have the FPS at the same exact number as your monitor refresh rate. Let's say again that you have a 144 Hz monitor, you need to run constantly at 144 FPS in order to have a fluid tearing free experience. Because as soon as you go over the 144 FPS, you'll have tearing, and if you go below that number, you'll have stuttering, which is not optimal. While when using G-Sync, you have kind of a range, usually for example for 144 Hz monitors. The range is usually in between, let's say, 38 to 144, and that means that in between 45 and 144 FPS, you won't have any tearing because the monitor will adjust its refresh rate according to the FPS that you're getting, and that's why the experience is so much smoother. While with VSync, that doesn't really happen, and you really need to have that specific amount of FPS, otherwise you'll have stuttering or tearing. So what to do? Well, just use 3D application settings, just leave it at default. You don't really need anything besides that, especially if you're using G-Sync or FreeSync or VRR, you don't really need that. Then we have a really interesting option, which is virtual reality variable rate super sampling, which according to NVIDIA, this variable rate supersampling option targets image quality improvements by applying supersampling selectively on a central region of a frame where it matters the most for virtual reality headsets. As a prerequisite or requisite, the application needs to be profiled by NVIDIA and have MSAA enabled. Multi-sampling anti-aliasing, the maximum supersampling factor can get applied is limited by the level of MSAA used in the application. The option is available on NVIDIA Turing GPU architecture, so only for the newer GPUs. And this is one of the things where NVIDIA is much better than AMD. Virtual reality. AMD is kind of okayish and it will play most games and so on, so on, so on. But in terms of general quality and in terms of general performance, NVIDIA cards kind of blow AMD cards out of the water, especially on RDNA 3, since they're still having some issues because of the architecture and so on, being multi-chip module design and so on. And NVIDIA cards just work much better. And on top of working much better, they also have things like these, the variable rate super sampling for virtual reality. For the common user, what it does is that it improves the image quality on the center of the monitor, which is actually where you're looking at. Because if you're using a VR headset, you're looking at the middle of the monitor. And as soon as you look, for example, to the top part, you do this. So the top part is now the center of the monitor, and this is the center part where it increases the quality, where you are looking at, where you are focused at, and these parts will still be the same. These parts on the side, kind of out of focus, will get the same quality, but where you're looking at will get improved quality with variable rate super sampling. So if you think that the game that you're playing, the virtual reality game that you're playing, needs better quality, you can use this variable rate super sampling. It will most likely get you lower FPS. You can select always on or adaptive, but you'll also get better quality. And now we have the program settings, and as I told you before, the program settings are basically the global settings on a per app basis, alongside with the in-game settings. Let's say that we go to The Last of Us. As soon as you open the game, and by the way, you can add new games here, you can select refresh, add a program where you add the executable of the game, and in case the software doesn't read it, you can add a scan location or restore the driver settings, then you can select filters, optimize all, and so on. And as soon as you open the game, you'll get presented with several in-game options. And this is also a thing that AMD does not do. AMD kind of lets you select the global settings again on a per app basis, and now the light went down, but it doesn't let you select the settings in the game. And if you choose these, the settings inside the game will actually change as well. And of course, most people won't use these settings, and this is actually not needed generally because people just go into the game and select the settings that they want. But if you want to do it through the NVIDIA software, you can just do it. Or if you don't really know which settings you should be using or not, if you're really new to computers, you can just press optimize, and NVIDIA will give you kind of the recommended settings for your GPU according to their tests. And if you go here, for example, as soon as you mess around with the slide, the in-game settings, the preview value will change. Like the AI quality, like the ambient occlusion denoise quality. For example, as soon as I go to the performance mode, it disables the shadows quality, animation, and so on. As soon as you go further to the quality side, it will also increase things like instead of having anti-aliasing, you have DLAA, then you have bounce sliding, then you have the character level of detail going from high to ultra, and so on. And this is the recommended value that you have here. But if you go to the bottom, now you have those driver settings that we saw before in the global settings, but on a per app basis. So if you select and change the driver settings here, like for example, if you pick dynamic vibrance, or if you pick the SR, low latency mode, monitor technology, any setting of these that you pick here will only apply to Starfield. It won't apply to Senua's Sacrifice Hellblade 2, it won't apply to The Last of Us, it won't apply to Counter-Strike 2 or Dragon's Dogma. So if you're playing, let's say, Counter-Strike 2 and you just want really low latency, you can just go here and select Ultra, and the setting will only apply for Counter-Strike. Or let's say if you want to use RTX Dynamic Vibrance just for Counter-Strike 2, you can just go here, for example, enable the Dynamic Vibrance. Then you have the intensity and the saturation boost, like I told you before. Yes, it is a saturation and intensity, like sharpening and saturation. You can just go press apply, and it will apply only to Counter-Strike 2. For example, if you go to Dragon's Dogma, yes, the RTX Dynamic Vibrance is disabled, and the same applies to the other settings. Again, if I had other GPU, I could use the 4060 to run Counter-Strike 2, that isn't a really heavy game, but I could use, for example, the 4080 or another card that I had, of course, to run Hellblade 2. And these driver settings are what they are the global settings just on a per app basis. Then we have the system menu, and we have 4 submenus: the displays, video, performance, and My Rig. As soon as you open the G-Sync menu, you have the option to select on full screen or full screen and windowed mode as well. So if you want G-Sync to work with windowed applications, you can do it by selecting full screen, and windowed mode as well. If you just won't, leave it at normal settings because it will apply to full screen applications normally. Then it shows the display settings with the monitor that you currently have, and it shows that I have the OLED G42P5. In this case, it's a KDC monitor. Thank you, KDC, by the way. 42 inches, OLED, and 138 Hz. Then you have the monitors. You can identify the monitor. This is the monitor 1. In case you have several ones, you can see which one is. Then we have the display properties because it will appear like this. So G-Sync settings off, connector display port using PC display, of course, because I'm using DisplayPort instead of HDMI, HDCP, sorry, 4K, like I told you, 138 Hz. Then you have the option to allow G-Sync settings for selected variable refresh rate displays. So this monitor isn't really G-Sync, but it does support VRR, meaning that you can allow G-Sync for VRR monitors. And as soon as we do it, we will enable G-Sync on this specific monitor. Again, then we have the connector using DisplayPort. It even has the icon for DisplayPort, which is actually a nice touch. Then we have the resolution, refresh rate, HDPC status, and HDPC is high bandwidth digital content protection and is a technology designed to protect high definition content. Do you need it? I believe not. On top of that, you have the orientation, and you can select landscape, portrait, landscape flipped, or portrait flipped, and that's it for this menu. Then we have the video options with RTX video enhancements, and this one is important, so it should appear like this, and as soon as you open it, you have the option to use video super resolution. And according to NVIDIA, Video Super Resolution uses AI to upscale resolution and reduce compression artifacts on videos played in supported browsers. Status indicates if RTX Video Super Resolution is active and the quality level currently applied. Typical usage scenarios: full screen video playback on 1440p or higher resolution panels. So if you just go here, go to the Video Super Resolution and enable on, you can select then several quality modes, 1, 2, 3, and 4. I won't swear because I don't really know, but I believe that 4 should be the better quality. Let's say I have a 4K monitor, but I'm playing a 1080p video. As soon as I go to my browser and I run a 1080p video and I go full screen, what happens is that the RTX Video Super Resolution will upscale that 1080p video to 4K, which is my monitor resolution. If I have a 1440p monitor and I'm playing a 1080p video, what happens is that it will do the same. It will upscale the video that I'm watching on YouTube, for example, from 1080p to 1440p. This if I'm running the video in full screen. At least it should make the video look better, like you see here passing right now on the screen. And on top of that, you can select the High Dynamic Range HDR that uses AI to convert SDR color space video to HDR, requires HDR compatible panel and HDR enabled in Windows display settings. And again, this is more like the RTX HDR, so if your game does not support HDR but your monitor does, you can select the RTX HDR in order to enable HDR in non-HDR content. And again, NVIDIA showed that several YouTubers tested it, and according to them it works very well. So I personally didn't really test it because again, I don't like HDR and I've used it several times. I just don't like it. But yeah, people that used it say that it looks very well. It looks very close to native HDR while using just AI to go from SDR to HDR. And if you enable the settings, you can just select the peak brightness, middle grays, in terms of nits as well, so kind of brightness or punching, contrast in percentage, and saturation in percentage as well. So you have several options, which are really nice too. And again, people that tell me they use HDR daily, they say that RTX HDR is a blessing. They just love it and they use it basically on every application. But again, for people that use HDR a lot. Then we have the performance menu that starts with the statistics with GPU clock, GPU power, GPU temperature, voltage, VRAM clock, utilization, CPU utilization even on top of that, and GPU fan speed too. Then we have the automatic tuning, which is one thing that they added, at least they added to the NVIDIA app because they already had it before, but they added it to the NVIDIA app a couple of months before the NVIDIA app became official because it was in beta for like almost a year, I guess.
Just do it!
Automatic tuner, which finds the best overclock settings for your GPU and maintains that performance on a regular basis. And you can enable it and it will start kind of a cycle doing the automatic overclocking, finding the best GPU tuning and VRAM tuning options. I did it for 2 different GPUs in several cases, and I even have a video showing it that you can see right here when I tested the NVIDIA app that was on beta, and at least before it didn't work as expected. It did increase the GPU tuning, so it did overclock the GPU, the core itself, by a little, like 100 megahertz or something like that. I could overclock the VRAM like 1500, yes, you're hearing right, 1500 megahertz, and it would overclock the VRAM to like 200 megahertz, so it was really a letdown. But again, this automatic tuning is kind of worthless because on the bottom you have the performance limits with a maximum voltage, maximum power, and a temperature target. And I can tell you right away that these settings come like this, so the power maximum comes at 100% and the temperature target comes at 83 degrees, at least for the 4060. As soon as you just increase the maximum amount of power, it means that the maximum amount of power the GPU can use will increase. And if that maximum amount of power increases, it means that the GPU clocks will boost higher automatically because they have more power to use, and with more power comes more responsibility. Or in this case, with more power comes higher GPU clocks, and this is just kind of a guaranteed performance increase in some scenarios. If you just increase the power maximum, you'll have better performance without needing to increase the GPU tuning or the VRAM tuning or to do the automatic tuning. Just do this, increase the maximum power and increase the temperature target, and if your temperatures are fine, you're good to go because the performance will increase as well. And the last submenu is My Rig, which basically contains the rig details with the operative system, in this case Windows 11 Pro, with a version of Windows as well, the driver details 566.14 as well, the CPU, the Ryzen 5 5600X, 16GB RAM, and if you want to go to the NVIDIA control panel, you have a link to do it. And that's what it has, nothing more. And the redeem menu is the only thing that kind of forces you to do a login. So in this case, if I want to redeem these in-game, some jewels or something like that for Throne and Liberty, I have to do a login. As soon as I press redeem, as you can see, it sends me to the NVIDIA login process, and I don't really want to do that. So let's say you buy an NVIDIA GPU and they offer you some games. Those games will most likely appear here on the redeem page and you'll have to log in. And that's basically the only thing that you have to log in into. So you enter the coupon code, the games will appear here, and as soon as you want to redeem them, you have to log in. But that's about it. That's all. Anything besides that, you don't need a login for anything. That's how it works. And the final menu is the settings that has features, notifications, and about submenus. And in the features we have the overlay, the NVIDIA overlay that we'll talk about and we'll see pretty soon, that you can just press Alt+Z and the overlay will appear. Then we have the game filters and photo mode. For now, let's disable it. Then you have the drivers with the option to automatically download drivers and let me choose when to install. Generally, I don't really want to do this. Then we have the games and the applications and you can scan them now, or for example, you can view and modify locations. Imagine that the NVIDIA app isn't recognizing your game. You can just modify the file locations and tell the NVIDIA app, it is here that I have this game, and the NVIDIA app will do it. Or if it isn't able to do it, you can just go to the graphic settings once again, sorry, and add the program manually. And then we have the automatically optimized newly added games and apps. This is the thing that the software will ask you as soon as you launch it for the first time. It will ask you if you want to optimize the newly added games and applications. I don't want NVIDIA to mess with my in-game settings, so I always press no. And in my opinion, you really shouldn't do it unless you don't really know what you're doing by any means. As for the notifications, we only have notifications for driver updates, available rewards, and I usually just uncheck both of these boxes. Just uncheck them, because unless you really want driver updates, some people really do, so in this case just leave this one enabled. And if you want to see the rewards, like the reward that we have here, for Throne and Liberty, if you want the application to give you a notification of these rewards, just do it. In my opinion, I just don't really want any notifications, so I uncheck both these boxes. And then we have the About, which now gives you the data about the NVIDIA app itself, with a version of the NVIDIA app, with early access, where you can select the option to receive access to early builds. Let's say that NVIDIA keeps putting more and more features in the NVIDIA app. You have the regular version, the official version of the NVIDIA app, but you'll have beta versions of the NVIDIA app as well that can contain certain features or certain applications that aren't still released for the general public. But if you want to test those new options or those new applications on the NVIDIA app, you can just check this box of opt in to receive access to early builds, and the system will download and will update to beta builds of NVIDIA app in order for you to see everything that's new. And by default, this box comes checked, and I advise you to uncheck this box because NVIDIA does not need to know about your configuration, performance, and usage data. They do not need, because they already have the required data, so the telemetry as they call it, and they don't really need more than that, so let's keep it that way. As for here, we have several other links for other things that you might want to see, like release highlights, NVIDIA accounts, and so on, so on, so on. And to finalize, because I'm really tired of talking, it's like over an hour talking, we have the NVIDIA overlay that you can press Alt+Z, or you can just go to the right top corner and press here. And this is one of the things that I don't like really. The AMD software in terms of overlay settings and so on is so much better.
Everything just works. Everything just works.
I still don't understand why I need this bar, kind of the overlay here, instead of the settings being on the NVIDIA app as well. The settings for the overlay should be on the NVIDIA app. We should have another menu saying here NVIDIA overlay, where we have the settings inside the NVIDIA app, which would be much easier for newbies, much easier for advanced users, much easier for everyone. And on the top of that, it would just look much cooler. For example, if I'm using the NVIDIA overlay, as soon as I click on desktop, bam, the overlay disappears. The overlay should appear inside the game, for example, when you press Alt-Z inside the game. But anything besides that, it should get, or the options just should be here on a special menu for the overlay. As for the options, we have the gallery. If you did several recordings, they would appear here in the gallery, like Counter-Strike 2, Dragon's Dogma, whatever the recording you did, like the desktop, it doesn't really matter. Then you have the option to start recording. You can select Alt plus F9 to start recording, or you can just click here and it would start recording. The same applies for the instant replay. Then we have the option to do the same for screenshot. Then we have the photo mode. Instead of going for the photo mode inside the game, if the game does not support photo mode, you have some really interesting options here. When taking a screenshot, you can select the resolution, you can show a grid, you can select the camera roll and field of view, which is nice, and you can kind of add some filters on the fly inside the game, which most people won't use, of course, but is an option that if you want to use it, it is here. Photo mode. Then you have the highlights that automatically captures key moments or key gameplay moments. You can once again select it, enable or disable, and this is just for selected games. Not every single game features the highlights option. Games like Fortnite, PUBG and so on, they support the highlights option, and the highlights will work with those games, but not with every game. Just take that in mind. Now you have the option to configure the video capture as well of the highlights, this desktop capture and so on, but we'll get there, sorry. Then we have game filters, like I told you before, and dynamic vibrance and sharpening, like the image scaling is indeed a filter, like I told you. Then you go to the NVIDIA overlay and select RTX Dynamic Vibrance in the middle of the game, and it will apply. And you can see the difference on the fly, which is very nice in my opinion. In the bottom, you just have the microphone option, toggle it on or off, nothing really new. Then we have the statistics. As soon as we go to the statistics, you have the option to show the statistics in heads-up display. As you can see, as soon as I enable them, the statistics are here. We have, for example, the RPMs, the megahertz, the GPU utilization, the CPU utilization, latency, and so on. We can configure the heads-up display, which leads you to another menu where you can select basically the position, like you see, upper center, the right upper, or you can select the horizontal position in a manual mode, vertical position the same way, as you can see. The layout, where you can select linear, double, or even stacked, like we usually see on the NVIDIA videos. You see that it is stacked this way. Then you can select the background opacity. Now it looks more like an overlay. You can select the font size, standard, large, and you can select, for example, the color as well. Usually we just use white. Then you have the status indicators like record, instant replay, highlights, and so on, that will appear here as it shows in the preview. So you have the microphone 1, the highlights, the recording. I believe that this is the recording or the stopped recording. Then you can select also the view that you have. In this case, we are running the advanced mode that has FPS, GPU utilization, and so on. You can just go here, for example, for the custom and select the ones that you want to use. You can view all, like GPU power, GPU fan speed, VRAM. If I want to use, for example, the render latency, reflex monitor position, mouse latency, PC plus display, I can select everything that I want to show here. A nice overlay with lots of features once again. MLAT, RLAT, TCL, and we can start logging by pressing here, of course, start or stop logging, and the log file locations. And the last one that we have is Reflex Analyzer, which is a monitoring rectangle flash indicator and latency samples. As soon as you opening, you have the LDAT support, and I believe that it is here that you actually need that physical LDAT, I don't really know how to call it. It's called the LDAT. You need that physical hardware in order to use the Reflex Analyzer or the LDAT support, which keeps the flash indicator visible when overlay is disabled or a reflex supported monitor is not connected. This will also make the flash indicator larger to enable measurement with LDAT, and you can use Reflex Analyzer with LDAT as well, but you need, once again, the LDAT hardware. So now let's just disable the statistics and go to the last menu, finally, to the last menu, which is the settings in the NVIDIA overlay. And you go to the settings, you have the shortcut controls, where you select all the shortcuts for all the things that we've seen so far, like the open or close the in-game overlay, toggle microphone on or off, push to talk, the statistics. If I press Alt plus R, let me see if it works. Yeah, I have the overlay enabled, so I guess it doesn't work with the overlay, but let's just try Alt plus R, and as you can see, overlay enabled, disabled, enabled, disabled. Now Alt Z for the overlay. Let's go back to the shortcuts. We have several things: start logging, toggle profile 1, save last 7.25 minutes recorded. Everything that you can do is here, and you can change the shortcuts as well. Then we have the heads-up display, again with the display settings that we've seen before. Instead of going to the other menu, you can go directly here to the overlay. Then we have notifications with show notifications for everything that you want, like for example for the recording. If this is enabled, a notification will appear on the right top corner saying recording has started, and if you stop the recording, it will appear recording has been saved. That's what it does for instant replay, screenshots, and so on. Notifications, simple. Then we have the audio, where you can select the volume of the recording and the system sounds, the microphone, the source, and so on. And if you want to boost with some dBs in case the microphone is too low, and you can choose the format of the audio track as well. Let me just see what it shows here. Yes, single track. And basically what it does is that you can select a separate track, and the software will record the video in one track and the audio in others, so separately. So you can just mess around with the audio separately from the video. Then we have the video capture, which is one of the most important parts of NVIDIA's overlay, at least for me, because again, I use NVIDIA overlay, NVIDIA software to record my videos. Not this one is actually using OBS, but apart from that, every single one of them uses the NVIDIA and AMD software or Intel software as well. In this case, we have several quality options like the low, medium, high, and custom. And if you go to the high settings, you can see that the only thing that changes is basically the Mbps, the video bitrate. Then we have the resolution, and you can select the in-game resolution, 360p, 480p, 720p, 1080p, 1440p, 4K, and you can even select 8K 30 FPS. Which is one of the things that isn't supported by the AMD cards. The AMD cards, at least on their software, only record up to 4K. They can do 4K 120 FPS, but again, they can't do 8K. And these cards, even the 4060, can record at 8K, so that's a nice thing. We also have the instant replay, by the way. If you want to select the length of it, up to 20 minutes, of course. As for the resolution, we see it right now. You can select the in-game resolution, as it will record as the resolution you're playing at. If you're playing at 1080p, it will record at 1080p. If you're playing at 1440p or 4K, it will record at 1440p or 4K. On top of that, we have the frame rate options, and before the NVIDIA app, we were only able to record at 30 and 60 FPS. And NVIDIA app added the option to record at 120 FPS, which is actually very, very nice. Now you might say, well, but why record at 120 FPS? I mean, you go to YouTube, nobody plays videos at 120 FPS. Most videos are still at 30 FPS. And if we go to Twitch or something like that, it's either 30 or 60. Well, 120 FPS video recording is mostly used for slow motion. So if you want to record some gameplay footage to later do a slow motion of it, you can go to 120 FPS. And if you slow motion those same videos both at 60 and 120 FPS, you can see that the 120 FPS video looks much better because it has double the information that you have with 60 FPS. So it would look much better normally. This is a really important thing about the frame rate, because as soon as you increase you see, for example, 60 FPS, the bitrate goes to 50, but as soon as you go to 120 FPS, the bitrate goes to 100. And that happens because the video bitrate is the most important thing. People usually look at resolution as the quality of the video, but resolution isn't the quality of the video. What gives the video its quality is the video bitrate. Let's say that the resolution is kind of a canvas. So the higher the resolution, the bigger the canvas is. Then you need information to fill in that canvas, and that is what the video bitrate is. So if you have a big canvas but you don't really have enough information, what will happen is that the canvas will suck. And that's what happens, for example, in some videos that you see, some 4K videos that you see on YouTube. But when the video starts and they start moving, for example, the gameplay, they start moving and so on, you see lots of squares, lots of pixelation, and that happens because they have a big resolution of 4K, but they do not have enough video bitrate. They do not have enough information to fill in those pixels. And since the pixels do not have enough information, they will just show a pixelated image. Now, my advice, if you're using 60 FPS and if you're playing, if you're recording, let's say at 1080p, I would say that 30 Mbps is more than enough. If you're running at 1440p, I would aim for, let's say, 50 Mbps in order to have a really, really good quality in terms of recording, at least a decent quality. And if you're going for 4K, I would aim for at least 70 Mbps. I would go higher if possible, but at least 70 Mbps in order to have a really decent quality. But as soon as you increase the frame rate to, let's say, 120, I do advise you to have a lot more video bitrate, because you are doubling the frames, meaning that with the same resolution, since you have double the frames, you need way more information to fill in those frames and those pixels. And in this case, I would say that 4K would need, let's say, 150, I believe it's supported. Yes, I would go for 4K 120, I would go for at least 100 Mbps, and if I could, a bit more than that. If you would go, let's say 1440p, I would say that 90 would be okay, 70 would be okay, but I mean, it depends on what is the quality level that you want. If you are using, let's say, like 10 or 20 Mbps at high resolution, high frame rates, then you go and watch your videos and say, well, the quality is crap, it just looks like crap. That's because of it, because the video bitrate needs to be higher. And the final thing that I want to talk about is the codec. Video codecs are very important because, of course, resolution, frame rate, and especially the video bitrate are very, very important for the video quality. But the codec is also very, very important. You can watch this video that I made comparing AVC versus AGVC versus AV1, with AVC being H.264, AGVC being H.265, and AV1, well, being AV1, and you have several comparisons at different resolutions and different video bitrates to show you that there are lots of differences in between codecs, because the codec is what kind of interprets the image, or I believe that's how it's pronounced. The codec is what reads the content and makes it into the video. So the more efficient the codec is, the better the quality it will bring at lower resolution and especially at lower video bitrates. For example, if you compare, let's say, if you are running, let's say, 10 Mbps, only 10 Mbps, if you compare, let's say, AVC to AV1, AV1 will deliver much better quality at 10 Mbps, and all the settings are equal, just the codec is different, and AV1 will deliver much better image quality. Let's say you're recording at 4K 120 FPS and you just picked like 50 Mbps, and 50 Mbps won't be enough. If you're using AVC, the final image quality will be much worse than using AGVC or especially AV1. If you're using AV1, even with the same settings, AV1 will kind of read the content better and will produce a final video recording better than the one from AVC or AGVC. So the same settings but with a better codec will also deliver, of course, a better image quality. And this is one of the things that I don't like on the NVIDIA software, because it kind of makes you use AVC and it will just go to AGVC automatically if you're using 4K resolution. So you can either select AVC/AGVC or AV1. You can't just select AGVC manually for lower resolutions and so on. As soon as you go, for example, as you raise the video bitrate, the differences in between AVC, AGVC, and AV1 will be really small and mostly unnoticeable for the common user. It is basically when you are using lower video bitrates that you can see differences in between those codecs. And lower video bitrates are usually used for streaming, not recording. So if you can, bam, bitrate to the maximum to increase the image fidelity as well. And well, guys, that's all for this video. I've been recording for, let's say, almost 2 hours. That's insane, actually. And I'm really tired. I wasn't expecting that. And I believe that you weren't expecting that as well. Definitely. I tried to explain the options, all and every single option, the best way I could. I believe that NVIDIA still has a lot to improve here, the same way AMD does. NVIDIA can make some things better, some things way better here, like the overlay. They should be getting a menu specifically for that on the NVIDIA app, and then just leave the overlay for the in-game. When you're in-game, just use the overlay. If you're not in-game, choose the settings on your app, not on your overlay. That's what I advise NVIDIA to do right now, but I guess they already know that. And if you have any doubts, or if I was wrong by any means, leave a comment in the comment section and let me know what you think about the things that I said, if they are right or wrong. And if you have any doubts, I will try to respond to you or to answer your question as soon as possible. Thank you very much for watching once again, and if you were crazy enough to watch the video to its full length, just leave a comment in the comment section, because I really want to know. That really means a lot to me, seriously. So if you watch the video from the beginning to the end, or almost, let's say, 70, 80, 90% of the video, just let me know in the comment section. I really want to know. Thank you very much, guys, and see you in the next video. Cheers.
Wow.